All right, in this video, we're going to look at a handful of different equations, either that have logarithms or that will need logarithms in order to solve. And I'm going to try and step you through my thought process on how I'm going to solve these. And we're going to use some different tools. There's going to be a little bit of factoring. There's going to be a little bit of division. We're going to see what do these equations look like. So the first thing I noticed for this one is that I have logarithms on both, or sorry, I have two logarithms on this side of my equation. I know that I always just want one log, so I'm going to combine these or condense them using the product rule. So because there's addition here, I'm going to use the product rule. The product rule says that I should be able to multiply this argument and this argument. So that is going to give me the log base 6 of, well, this is a large, or it's a binomial, and so I know that x is going to go here and it's going to go here. So that's going to give me 2x squared minus 6x, and that is equal to 2. So first thing I did was use the product rule to combine. Product rule says to multiply this argument by this argument. Because it's a monomial and a binomial, I distribute it. Now I'm ready to get rid of my log. The easiest way that I know to get rid of my log is to exponentiate both sides. So I'm going to use the base that's given to me, and I'm going to turn these into exponents. So this is going to become 6 to the log base 6 of all this is equal to 6 squared. This is useful because this side cancels, or that information cancels, leaving me with 2x squared minus 6x is equal to 36. So now I've actually gotten rid of my logarithm. I'm actually off to a great start on how I can solve this. One of the first things I notice in solving is that this is squared. If this is squared, if I have an x squared anywhere, I should be thinking about factoring in order to solve this. In order to solve this using factoring, I know I have to set it equal to 0. So I'm going to bring that 36 over. X squared minus 6x minus 36 is equal to 0. So I brought that 36 over. Now I know that I could start factoring it immediately here, but I also noticed that every single one of these is an even number, so I can actually just divide out that 2 completely. That's going to make it a lot easier to factor. So it's going to give me x squared minus 3x minus 18 equals 0. Now, factoring, there's a lot of different ways to do it. I know in general, I'm looking for what two numbers multiply to give me negative 18, but add to give me negative 3. So negative 18, I automatically think about 6 and 3. I need them to be negative, so one of these needs to be negative. I need them to add to a negative number, so the negative 6. So I'm going to check that really quickly. Negative 6 plus 3, that's negative 3. Negative 6 times 3, that's negative 18. So I'm ready to go. Now, really important, as I go to write this over here, I can only do this shortcut I'm about to do because my a term is 1. So because I don't have a coefficient here. If I had a coefficient here, I would have to do factoring via grouping or using the box method. But because there's no coefficient, these numbers are what go into my factors. So my factors become x minus 6 times x plus 3, and that is all equal to 0. Super close to being done. We have to now just set each of these equal to 0. So I have x equals 6 and x equals negative 3. Wow, I have solved for x, which is awesome. So once again, I'm going to step you through what I did. I'm actually not done yet. We're going to see why. So first thing I did was I condensed these using the product rule. Condensing them said that I need to multiply the x out, or the x to both of these. I then exponentiated both sides using the base of my logarithm. This side canceled, leaving me with just the argument. This side I evaluated. Because I saw an x squared and an x term, I know that I probably need a factor in order to solve this. That's the only way that we're going to go about solving something like this. So I subtracted my 36 to the other side to set it equal to 0. I noticed each of these were even, so I divided by 2. And then I went about factoring. I was looking for my numbers that were going to multiply to give me negative 18 and add to give me negative 3. I put those into my factors, and then I set each of these equal to 0 to solve these out. Now, a lot of this inside stuff, honestly, everything in the dark blue and the pink, that comes from quadratics. That has nothing to do with logarithms. This last bit does have to do with logarithms, though. We know that any argument has to be positive. So in this one, I actually have two arguments that have an x in it. Both of these must be positive. So 2x minus 6 must be positive, and x must be positive. I have to try both of my answers to see if they work. So for this one, it's going to be 2 times 6 minus 6. Well, that's 12 minus 6. That's going to give me a positive number. Here it's just 6. That's a positive number. 6 works. Negative 3 is going to be 2 times negative 3 minus 6. Well, that's going to be a negative number minus a negative number. That's not good. Automatically doesn't work. But I could have also checked the other one, which is just plugging in here. Negative 3 is a negative number. Does not work. That's an X. That's a frowny face. So what I'm going to do is I'm actually going to cross this off. We call values that do not work extraneous solutions. So values that do not work, values that we solve for that do not work are called extraneous solutions. On an assessment, on any type of assessment, our final answer here is just x equals 6. So this is something a lot of people get confused on. They want to include this, but because it does not work, it is not in a solution. Our final answer here is only x equals 6. At the beginning of this video, I said I was going to do a handful, but this video was slightly longer than I meant, so I'm going to come back in another video to do 1 or 2 more practice problems.